All right, good stuff. Hi, everybody. That was pretty terrible. Just terrible. Try again. Good morning. There you go. Good stuff. That photo, I think, I could be wrong, I think that photo was a little old. That's actually the photo of the labs office in San Francisco was, got to be at least a couple years. We've been doing this, we've been doing the stand-up, morning stand-up for years and years and years. And we do it every day, and it's a very good idea. But that photo featured somebody, he was the director of happiness at Pivotal Labs San Francisco. Do you have a director of happiness in your organization? We do. But we have a new one now, so that one is no longer there. All right, my friends, we don't have a lot of time. We have very, very little time, in fact, so we are going to get started. As always, I begin my presentations with this slide. I would encourage you to note this slide. This is the most important slide that you're going to see in this hour, in this day, right here, okay? So if you take a photo of one slide, this is it. This contains both the code that you need to be able to follow along at your own leisure, at your own discretion later on, should you have questions, comments, feedback, whatever. It also contains my coordinates, right? So if you want to ask questions, if you want to reach out to me, if you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I'm on Twitter. I'm just curious, how many of you are on Twitter? Twitter? 2019? Twitter? Almost 2020. Almost 2020. So the rest of you, get on it. What are you doing? It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are. You owe it to yourself to be there. What about email? Who's using email? Does anybody use email? Email. No, good. Moving on. I'm not a real big fan of email, although I've had to soften my position on that in light of Slack. I prefer email to Slack. I have here, you can't see it, I guess. You can't really, it's not manifestly visible, but I have here a MacBook Pro 2018 with 32 gigs of RAM. And I bought this at the time because it was the top of the line machine. And my hope was that with 32 gigs of RAM in a MacBook Pro, I would be able to run both Slack and Chrome at the same time. And we're not there yet. But did you see they just announced a few months ago, they announced a Mac Pro with 32 gigs, with 1.5 terabytes of RAM? Wow. That's enough to run both. It says in the bullets, it can run both, right? That's amazing. And yesterday they announced a MacBook Pro 16-inch that can do 64 gigs of RAM. So guess what I'm going to go buy for Slack and Chrome, right? I need it. Okay, my friends, so that's that. That's my coordinates. Now that we're all here, I want to take a quick selfie, okay? I want to take a selfie with all you. And the reason is because I have a daughter, and my kid, she's really smart. She's smarter than I am, certainly. And so whenever I go to these audiences all around the world, I talk to people in dozens of countries every year, and I love being in front of people like yourselves, smart, entrepreneurial types. And the reason is because I get to meet great people, and I come to these great audiences, and I have these amazing audiences, and I like to take these selfies, and I take these photos of these selfies, and I go home to my daughter, who's a teenager, and I say, see, they listen to me. So we're going to take a selfie together. Is that okay? Okay. Everybody just pretend like you're happy. Pretend like you're happy. Oh, it's going to be so good. When I say open source, you say open source, and then just pretend like you're happy, and we're going to do it together, okay? Ready, steady. Open source. Oh, yeah. Good stuff. Right on, my friends. Thank you. So we have very little time, so let's get to it. First and foremost is that my name is Josh Long. I'm a Spring developer advocate on the Spring team. Have been for better part of 10 years now, going on 10 plus years. Unofficially, it's been a lot longer than that, of course. I work on the Spring team. They made a toy out of me in China last year. I thought that was kind of funny. You can find me on WeChat if you use that. I have training videos on Safari, lots of different training videos. These are all 5, 6, 7 hours of content. I have a book called Cloud Native Java, which is all about how to write applications that survive and thrive in the cloud. And the book is something that took a little longer than I expected it was going to take. I didn't mean for it to take so long. My co-author and I, we thought we'd be able to get this done very quickly, but it took a little longer than we expected. And there's a lot of reasons why a book might take so long. we were thinking maybe 6 months in and out, no problem, but it took, as we didn't expect, a little longer than 6 months. It took a tiny bit longer, not a lot longer, just a little, I mean, it was not a big deal, okay? It was just a very small delay of like 2 years, okay? Just a very small 2-year delay. Now, there's a lot of reasons for that. I don't want to point the finger at any one particular thing, but in addition to getting the book done, which we did, by the way, to be fair, we got the principal writing and editing and polishing of the manuscript done within about 6 months, but we spent the extra 2 years deliberating, going back and forth, sometimes intensely, sometimes cantankerously, sometimes arduously, over a topic that's near and dear to every O'Reilly author's heart, namely, the animal on the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't matter what's in the book itself. Nobody cares. Nobody's even read them. Have you ever read an O'Reilly book cover to cover? See, nobody raised their hand. Instead, what matters is what the animal on the cover is. So we spent a long time coming up with the animal. We eventually settled upon a blue-eared kingfisher. Now, I shared this with you in light of the haze over your skies of late, right? Because a blue-eared kingfisher is a bird that is indigenous, or as we say in English, native to the Indonesian Java Islands. It's a bird that is only found in the Indonesian Java Islands. And birds, they fly. They fly, yes, through the clouds, So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. It's a bird. It'll come. Give it time. That'll come. I've got a podcast every Friday. It's just me talking to people that are smarter than I am. Find that wherever fine podcasts are. It's called The Beautiful Podcast. Every Tuesday, a blog called This Week in Spring on spring.io/blog. Every Wednesday, a new video screencast on my vlog on YouTube called Spring Tips. And of course, I'm working on a new book called Reactive Spring. And that's the subject about which we're going to talk about today. Reactive programming is a fairly new response to an age-old question, namely, how do I handle more users? How do I handle more scale? How do I accept more requests coming in from the outside? And it's not hard to imagine the motivations for this particular challenge. In the last 12-odd years, we've seen a move, an exodus, if you will, to a new sort of client-service architecture. Now, we build clients that have backends driven by HTTP APIs or other kinds of APIs. And so as a result, every single user interface that you view in your modern world, in the world post-iPhone, post-Android, post-smartphone, post-smartbox and Roku and PlayStation, Xbox, and that one person using Windows Mobile, in that new world, every single user interface results in a cascade of API calls that go to the back-end services. And so suddenly, our ability to handle more HTTP requests becomes much more manifest, much more prominent. So the question is, how can we address that? How can we address that? And if we have trouble, why can't we address it? There are some answers here. There are some easy answers. One answer I quite like. One answer that we've known about for at least 10 years is called just scaling out, right? You move to microservices. You make sure that you excise any sort of state that's bound to a particular node, right? You move to a stateless architecture. You excise that state, and then you just throw those nodes behind a load balancer, right? And this is a great answer. It's a pragmatic answer, and I love this answer. You see, I work for a cloud computing company, and so every time you scale up a new instance, we make money. I love that. It's a great answer. But can we do better? Is there a way to do this a little bit more efficiently? Can we handle more users, more requests with the same JVM, with the same node? And if we can't, why not? Well, it turns out that whenever you have an HTTP request that comes into an HTTP service, typically the approach is that you've got a thread that's assigned to the request. So the request comes in, the thread kicks off, it handles the incoming request, the bytes come in from the incoming request, and then the code is just sitting there waiting for those bytes to be read in. Now, there might be delays, there might be outages, there might be topology boundaries and volatility in the network. And so as a result, you can't be assured that those bytes are going to be super quick. You can't be assured that they're going to be here instantly, right? We know this. These are the fallacies of distributed computing. We know that you can't rely on that, and yet we write code as though you can. We write code as though the next byte will always just be right around the corner. And that's just not the way of the world. We also write code assuming that the service will always be up. And that is just not the way of the world. So what we need is a new way to write code, a new way to write software that acknowledges the fact that the world is asynchronous. It's event-driven. There are going to be outages. There are going to be topology changes. And we need a way to respond to that. Reactive programming is a way to do that. Reactive programming gives you a computational metaphor that allows you to say, hey, I'm asking for some data. It's not here right now. And because it's not here right now, we can let somebody else use the thread that I was using when I initiated the request. If they can reuse that thread for some other work while we're waiting for those bytes to get trickled down and processed, great, right? We can make better use of the threads in our system. Remember, threads on the JVM are very expensive. They're not a cheap resource at all, so you can't just create infinite numbers of threads. And even if you could get beyond the fundamental sort of saturation point that is reached by creating too many threads, you can't actually use an infinite number of threads. Remember, beyond the number of cores in your machine, you don't have true concurrency. You have scheduling, right? This is an illusion. It's not real. So you'd actually get thrashing. You'd actually get context switching, which would make your code less performant if you added too many threads. So instead, what we try to do is to be able to better reuse, to better repurpose the existing threads. That's what reactive programming is all about. And my friends, the big first step in our journey came in 2015 when we released the Reactive Streams specification, pivotal, in tandem with Netflix and Lightbend and the Eclipse Foundation. We all released the Reactive Streams specification. This is a common ground API that gives us the types that we need to be able to describe asynchronous streams of data. On top of which, we have Pivotal's Reactor project and other similar projects like RxJava 2 from Netflix. These things support operators, filtering, flat mapping, composing of streams. All of that is super useful, but it doesn't actually allow us to get to production, not just yet, because these things, while useful, are more like reactive Java 8 streams, okay? They provide us a way to deal with streams of data. They don't allow us to build web services and to build data access layers and to handle security and so on. For these things, we need Spring. So in 2017, in September, so a little bit more than 2 years ago, we released Spring Framework 5, the first release to natively integrate a reactive web runtime. On top of that, we have since released modules including Spring Data, Spring Security, Spring Boot, Spring Cloud, etc., that all integrate reactive programming end to end, so that now, almost at the dawn of 2019, we have the ability to build end-to-end systems and services in a reactive way. And that, my friends, is the journey that we're going to explore today. And we're going to do that, of course, by going to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and WebSphere, start.spring.io. So we're going to build a new application, my friends. We're going to build a new application using start.spring.io. We're going to use the latest and greatest version of Spring Boot, and we're going to create a service here. It's going to be a simple service, and we have to confront some options. We have some choices, the first of which is the choice of packaging. People get confused by this, so let me do my level-headed best here and now to explain when and where to use which. If, by some freak fluke of physics, some terrible tragedy of time-space, you find yourself somehow transported to the distant, distant past, far, far, far beyond modern help, then of course, choose .war. But if you're here with me in 2019, then choose .jar. This is a big part of my overarching and guiding personal philosophy of make jar, not war. And again, lots of things you could do, but I encourage you to accept the defaults. Now, my friends, we also have the choice of Java version that we want to use. What version of the JVM do we want to use in almost 2020 for our applications? My friends, there are 3 choices here, only 2 of which are acceptable. I'll give you a clue about which one's not acceptable, about which one is inferior, it's wrong. That one, that's the clue. I couldn't be more subtle. That's the wrong one to use in 2019. Java 11 is the current long-term supported version of Java. Java 13 is the current version of Java, both of which are infinitely superior choices to Java 8. They're not just technically superior, right? They're also morally superior. Are you prepared to have that discussion with your children that you're still using Java 8 in production? I don't think you are, friends. I don't think you are. You need to do better. Now, we're going to use Java 13 because I can and I should, and we're going to bring in some dependencies here. We're going to bring in the reactive web support. We're going to bring in reactive MongoDB. We're going to bring in R2DBC to support SQL data access. We're going to be talking to a Postgres data instance. We're going to use RSocket. We're going to use Lombok, and voila, I think that's all I need for now. So let's generate our project, and that's going to open up a new project that I can then bring up in my IDE, and it doesn't really matter what IDE you use. I'm just going to open up inside of IntelliJ. Anything that supports Java 13 and Maven or Gradle will work just fine. Once we do this, we'll have a brand new application, and our application is going to talk to the database. So naturally, the first thing that we're going to do is describe the data type, the structure that's going to map to our data records. So let's do that here. We're going to create a new service, and we're going to persist entities of type reservation. So I'm going to create a new service, and it's just going to persist entities of type reservation. Let me make the font a little larger here, friends. A little bit larger. OK, there we go. So here's our new service. I'm going to create an entity of type reservation, like so. Okay? It's just going to be a thing that we're going to persist to MongoDB. MongoDB is a document database, and so in MongoDB, you have collections, which are like tables, and each row in that document is called in that collection is called a document. So I have a document here. I'm going to comment out the R2DBC support that we don't need just yet. So here's this, okay? And with this, I've got the basis of what I want to express. This is the basic thing that I want to express in my application. I'm going to persist entities of type reservation as documents in the MongoDB collection. The problem is that this is Java, and so of course I need getters and setters and toString and equals and hash code and all this good stuff. Create some constructors, more constructors, right? 2019, this is what Java looks like. That's embarrassing. So instead of doing all that, I use either any other language at all, or I can use Lombok, right? And they'll give me these compile time annotations that let me synthesize the getters, the setters, and the toString, and so on. With that, I want to create a repository to handle persisting instances of this record into the database, okay? Now, this is a reactive CRUD repository. Spring Data will look at the interface, it'll look at the prescribed methods on this interface, and it'll provide an implementation that does what we want it to do by looking at these names. And these names are fairly straightforward. You can see already what these things should do. There's save, find all, delete, count, etc. That's all fairly straightforward, but let's take a brief moment to talk about these parameter types, the first of which is a publisher. A publisher is a thing from the reactive stream specification that publishes, it broadcasts data to a subscriber that listens for the data asynchronously, out of band, okay? As new records arrive, they're passed into the onNext method. If there are any errors, or more usefully, when there are errors, they are passed to the onError method. And when we're done processing, those are passed to the onComplete method, okay? When we're done processing, that signal is relayed by invoking the onComplete method. Now, I briefly alluded to this, but I skipped over it because this is arguably the most important part of the whole reactive stream specification. OnSubscribe is where the subscriber is given a subscription. Each subscriber gets a unique subscription. It's a link between the producer and the consumer, between the publisher and the subscriber. And this link is how the subscriber requests more data or cancels the data. This is a very simple idea, but it's very important. The client controls the rate of consumption. It's client-managed flow control. Not a new idea by any stretch, right? As soon as we had one computer on the same network as another, we had to worry about flow control. This has been a decades-old thing, but now we have surfaced this concept as part of the API. We call this flow control, or in the world of reactive programming, where sometimes marketing prevails over common sense, we call it back pressure. So if you've ever heard the term back pressure, that's interchangeable with flow control. It's just a very simple idea. The client controls the rate of consumption. In this way, it's impossible for the consumer to be overwhelmed by an overeager producer. That is how you build robust services. They control the rate at which they consume the data. You can't denial of service a consumer that is driving its own rate of consumption. And that's what we have here. Now, we have these reactive streams types. They're very Spartan, very basic, very primitive, but they do work. They provide a foundation. Think of them as sort of reactive arrays. They're very basic, but they allow us to describe discontiguous streams of data. That said, they still lack some of the finesse, some of the utility that we have come to expect from things like the Java 8 Streams API, which provides all these different operators that we can use to do things like map and flat map and filter and so on. To support those particular use cases, we have two specialized types from Pivotal's Project Reactor, the first of which is a mono. Mono is inside of Reactor, as I said, but ultimately it implements publisher. Mono is a publisher that produces at most one value, so 0 or 1. Think of it like a reactive completable future. A mono also provides all these different operators. Look at all those different operators, just thousands of lines of code to support processing on streams of data. We also have something called a flux. Now, a flux is a publisher that produces 0 to n values, where n could be potentially unbounded. And that's it, my friends. If you understand those types, congratulations. You're certified reactive. You can go to Silicon Valley, raise millions of dollars, fail miserably, and come back a failure. You're ready. You're already years ahead of people in Silicon Valley, okay? But can we go to production with that? Is that enough? And I would say, no, it's not. We still have work to do. So we are going to use this repository to build software, to build actual things that we care about, right? So we're going to build an initializer. It's just an object that's going to inject that repository here, and we'll take that bean as a parameter in the constructor, which we're going to create here. We're going to say required args constructor at component. And there we are. There's my object. There's my basic bean. I'm going to inject this reservation repository. Okay? And there we go. Okay? Now, I'm going to use this to write data to the database. I'm going to create a reactive stream with just some names of people on the Spring team. My name's Josh. It's so great to meet you. I've got Madhura. She's on the Spring team. We've got Ria. She's on the Spring team. We've got Spencer. He's on the Spring team. We've got Olga. She's awesome as well. We've got Dr. Sire. He's awesome as well. We've got Dr. Pollock. He's awesome as well. And we've got Violetta. She's awesome as well. So all these are just people on the Spring team. I've created a reactive stream of string literals in my code representing a stream of values that I'm going to turn into things that I want to persist into the database. I'll just create a new reservation for each name, passing in null there, and that creates a stream of reservations. Now, you can see I'm using basic Java 8 streams like operators, right? These are reservations. Now, I want to save these into the database, so I'm going to visit each one of these. I could do map. I could do map just by calling that like this, and that would be OK, but look what happens. Map takes the result of this lambda, which in this case is a mono of reservation, and it accumulates that into a container type, which is another publisher. So I have a publisher of reservation. I want to flatten that out a little bit. I want to take the inner publisher and unpack it. And so to use that, you use flat map, okay? So there we go. There's my entire stream. Now, if I ran this program as written right now, nothing would happen. You see, this stream is cold. We've connected the pipes together. We've created a pipeline by connecting the pipes together, but there's nothing happening yet because we haven't turned on the faucet. We haven't turned on the water. There's no water flowing through those pipes. In order to turn on that water, we need to subscribe, okay? You can subscribe, and then you can provide a consumer or a reactive streams subscriber, or all sorts of different things, right? A consumer could be written like so, and you just say system out print line reservation. And of course, this can be a lambda, right? Replace it with a lambda, or a method reference. There you go, much better. And that's the entire thing. Now, consider what would happen, first of all. Let's first of all clean this up. Can we clean this up a little bit? I say yes. So let's just say, flatten that, and then chain these things together. Okay? There's this. And we can say now, I want to visit each one of those, and then subscribe. But even if I do that, what's going to happen? Well, on subsequent runs, I'm going to see the same data in the database rewritten multiple times. I've got 8 records right now. First time it'll be 8, then 16, and so on, right? I don't want to have redundant data in the database. So I'm going to delete everything first. I'll say this.reservationrepository.delete all. Now, delete all returns a publisher of void. It's an asynchronous type. So I can't just say delete all. I have to also subscribe. But that gets weird because subscribe is an asynchronous operation. We don't know on what thread that will run. So instead of trying to figure out that whole thing, we can use the operators to chain things together to deterministically say that this goes before that, okay? So delete all, then many, okay? And we say names, and then many. This.reservationrepository.find all. And then finally, we subscribe to the results, okay? So I'm going to create a logger here. I'm going to do that by using lumbuck again. I'll just use the log4j annotation to synthesize a logger. and I don't need this anymore. So the pipeline, once it starts, is going to delete everything in the database, then write the data to the database, and then find everything in the database, and then as the results start to trickle on back, we'll see that reflected in the output on the console there. Let's see if it worked, my friends. Did it work? Oh, look at that, huh? There it is. Each one of us reflected in the output in the console. It worked. You can see that these entities have gone to the database, they've gotten a UUID from MongoDB, and they've come back, and we can see that reflected here, even though up here I very clearly passed a null for the ID. So we know that's working. It's able to round trip. So it worked. Of course it worked. It was a demo. What were you expecting? That was always going to work. That's not why we're here. That's not what I care about. What I wanted to talk to you about was this. This is the Spring Boot ASCII artwork. We have a lot of people on the Spring team who are doctors, PhDs, people who in their previous lives worked in nuclear physics. So it makes me very happy to imagine that someday, somewhere, somehow, there's a GitHub issue that said, darn it, we need good ASCII artwork. And I think you can agree they did a great job. And so it's for this reason that I want to take a very brief, ever so brief digression to talk about what I consider to be a glaring and serious deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be a particularly short-sighted addition. Do you see this checkbox right here? This one right here, this one right here, this checkbox. Do you see that checkbox? That one right there, this one right here, this one. Do you see it? Do you see it? That checkbox right there. If you click it, don't click it. If you click it, that checkbox suppresses the output of the ASCII artwork. What the heck? Why is that there? That's a dumb feature. Nobody even asked for that, okay? Nobody even asked for that. So I did what all people would have done in the same outrageous situation. I went on the internet and I cried, and I was given a message of hope from my friend, Jan Sabron. Jan Sabron is a developer advocate at JetBrains. This is Jan right here. This is him. This is Jan. That's him. That's him. That's him. Boop. Anyway, he sent me this message of hope, which I want to share with you here today. I've known him for a long time, and I want to believe him when he says something. He's a friend. Every time there's a new release of IntelliJ, and I ask him, where's the feature? Where's the fix, man? He says, Josh, relax, chill out. It got delayed. We'll put it in the next one. It'll be in the next one. Just relax, Josh. The next one. He says that all the time, and I've known him for years and years, and I want to believe him. But you know what? I'm starting to think that maybe, just maybe, he's not exactly on the level. Anyway, we've got data in the database. We've got amazing ASCII artwork. The next natural question is, how do I build an HTTP API? We could use Spring MVC-style controllers, certainly, or we could create the new functional reactive style. I like this, right? Functional reactive, server response, routes, okay, return, route like this, okay, build, and .get /reservations, new handler function. And in order to support that, I can use the reservation repository, RR, server response.ok.body, rr.findAll, reservation.class, and there we are. Now, I'm going to comment this out, make this a lambda rather. There we are. Make that a static import. Very good. There's my new functional reactive HTTP service. I am happy with that. It's a very little bit of code. You can actually chain together these endpoints and so on, as you would, and you get the the nice builder-style way of building applications. Let me see. Okay, go. Okay, so now, localhost, reservations, and there's our data. It worked. It worked. Of course it worked. Now, I've been using MongoDB all this time, right? You can see that reflected in the output there. I've got those long UUIDs. We're using reactive Spring Data. Spring Data supports a number of different reactive data technologies, databases, right? We have a number of different implementations out there that you can use if you like. There's a few of them here. Where did I put that bookmark? Here we go. There's a number of different reactive NoSQL technologies out there that you can use. We've got Azure Cosmos DB, we've got Google Cloud Firestore and Spanner, we've got Cassandra, MongoDB, Redis, Neo4j, Couchbase, and Elasticsearch that are either all GA or in various stages of becoming general available. Now, these are all great choices, but the question I often get is, what if I'm doing SQL? What if I'm doing an SQL-based project, right? Well, this is a very common question. And to support that, we have something called R2DBC. R2DBC is a reactive relational database connectivity abstraction. And we have early days support for you. Now, keep in mind, it's not yet GA. I expect it'll be GA by the end of this month. That's what I was told. I don't know if that's going to be true. It might be a little bit later than that. But basically, we have R2BC support. It's experimental right now. It's experimental. So I want you to regard it with the same hesitation, the same skepticism, nay, terror, with which you regard PHP. Here's production. Here's PHP. Never the two shall meet. OK? Never. The same is true for R2BC for the second, okay? Wait a few weeks and then you can use it. But you should try it out now, right? We have a number of different implementations supporting, among other things, PostgreSQL, SAP HANA, MySQL, H2, and Microsoft SQL Server. So we have a lot of different implementations and more coming, okay? So I'm going to go ahead and use that. I'm going to comment out MongoDB here. And we're going to go ahead to our build, and we're going to change the code ever so slightly to accommodate the fact that these are fundamentally different data stores, and they have different requirements. So we're going to go to our repository, change this to a reservation without the document annotation. We're going to be using a monotonically incrementing primary key, so we use integer there and reflect that in the repository definition as well. There we go. Good stuff. Now, that's basically the same code. I don't have to do anything else. I don't mean to imply that by using Spring Data, you have this portability across different databases. That's not the goal by any stretch. It's just that this is such a trivial example. It happens to work. I tried to make this run, but I forgot to specify a R2DBC URL. So I'm going to specify this. This is going to be our little secret. You can't tell anybody, OK? Here we go. Localhost orders. Shh. Don't tell anybody. You shouldn't hard code usernames and passwords, but here we are. Such is the state of 2019. Here we go. OK, let's see if that works. Good stuff. There we are, huh? You can see that instead of UUIDs, we got primary keys, we got integers, and it worked. OK, so good. Now we have an HTTP endpoint. We have data in the database. This is fine. We've got 8 records in the database. We've got a JSON HTTP endpoint. Who cares? You could have done that yesterday, right? You don't need reactive to do that. Where does reactive really come into its own? Well, any place where you might have a thing that monopolizes a thread is a great place to use reactive programming. So anything that would have otherwise required you to monopolize a thread, what are examples of this? Well, suppose you want liveliness in your feed, in your data store. You want to be able to get instant updates to events or to messages or to status notifications or presence or chat or stock tickers, whatever. These kinds of things are all natural, ideal candidates for, oh yeah. These are all ideal candidates for reactive programming. So what we're going to do is we're going to create a service that produces an infinite stream of greetings. And this is something that I want to consume infinitely, right? So I'm going to create an infinite stream. I'll say class greetings service, OK? And it's just going to be it's going to create a stream of greetings responses given a stream of greetings requests. OK? Here we are. So at data, at allargs constructor, at noargs constructor, and here we go. Now, the request will have a name attribute, name, and the response will have a message, so string message. Good stuff. Now, there's the basic DTO. That's the thing. I'm going to create a simple service here, and the service is going to have an endpoint that'll give us an infinite stream of greetings responses given a single greetings request. OK, like so. So I'll say flux.fromStream, stream.generate, new supplier, providing a new greetings response. Here we go. Hello at greetings request dot get name at instant dot now. Okay? And delay elements duration dot of milliseconds. And let's say I'm going to delay it by 1 second. Each result will be 1 second. Now what I've done is I've created an infinite reactive stream using these operators, and I've delayed them. I've actually added a dimension of time to my code here. I've said I want each new item that's going to be produced every new second. I want to have a new item. I can do this because behind the scenes, Reactor has a scheduler. The scheduler is what moves things from one thread to another. It's what allows our code to be so effortlessly multi-threaded. It's the thing that takes work that is needing to be done and puts it on a thread. Now, by default, the scheduler that you get when you use Reactor is the scheduler that has 1 thread per core. Each thread is an event loop. What that means is that if you do anything that blocks, if you do anything that works by blocking the thread, and there's a lot of different things that qualify for this. There's Bitcoin mining, the Fibonacci series, cryptography, running Slack. I mean, these things all monopolize the CPU, OK? And so this is something you want to avoid. You can't make these things, you can't do these things on a particular non-blocking thread. If you do, then you end up blocking the number of users that are assigned to that core, to that thread. Remember, if you've only got 4 cores, you've only got 4 threads, you block that one thread, you've just blocked 25% of your users, not just one user, because it's not one thread per user anymore, is it? So we need to make sure that we know how to isolate things that might block, or we need to know how to move them aside into their own scheduler. And you can do this fairly easily. So for example, down here, when I created that pipeline, I could have created my own pipeline, my own scheduler like that. I could assign it to a custom scheduler. There's lots of different things you could do. You shouldn't need to do that, but if you do need to do it, you ask yourself why. What are you doing that requires that you create more threads to scale up and out? If you're scaling out by adding threads, then somewhere in the code, you're blocking, right? That's avoidable. And if you want to find out where you're blocking by accident, you can take advantage of our amazing project called Blockhound. Blockhound is a Java agent. You add it to the class path, and if you add it to the class path and you have a blockhound.install in your public static void main, then anywhere in the code where you're doing something that blocks on a Java thread that should be a non-blocking thread, it'll throw an exception. So here we're thread.sleeping, it throws an exception saying, hey, you shouldn't do this. Blockhound was built with Reactor in mind, but works with anything that's asynchronous. So it can help you with other projects as well. And as a proof of concept, we actually implemented one for Akka Streams as well. This is a very useful thing to have to isolate isolate blocking code from your non-blocking application. So now I have this infinite stream of data. I have this greetings service. It's infinite. I want to export that data to the world. And there's a lot of different ways to do this. I could use HTTP and server-send events, right? I could provide a server-send event endpoint that when I connect to it, it gives me a server-send event stream, which is just an ongoing stream. Now, this protocol is a very simple protocol. It's an HTTP protocol, and the client that sees it looks at the application content type and says, oh, I'm expected to just keep connecting, to keep my connection open to this endpoint, and it'll just keep the client socket open. This is one of those examples where you're blocking a thread, right? This is in the reactive world, you don't need to block a thread, right? Because we're not going to block. But this is one of those things where you could use server-send events, and you could use HTTP. The problem with HTTP are many. The problems with HTTP are many. I don't know exactly where to start, but there's a lot of issues that make HTTP a non-ideal technology for communicating from one microservice to another. HTTP is an old protocol that's porous. It's text-based, unless you're using HTTP2. HTTP2 is binary, right? That's an improvement. That's a little bit more efficient. But we still have some other problems. HTTP2 supports stateful connections, but it only supports pipelining, not multiplexing. So as a result, you're not able to handle a lot of requests with the same thread, with the same connection. If you want to do WebSockets, for example, WebSockets is a binary protocol as well, so it's also efficient. It also supports bidirectional communication, right? You can send data back and forth once you're connected. That's nice. But what about security? What about headers? How do you propagate headers inside of a WebSocket application? I'm genuinely asking. I don't know. As far as I know, there are no mechanisms in WebSockets to support propagating headers. You can do it with the HTTP initial upgrade endpoint, right? That can have headers. But in the WebSocket stream itself, the convention that we've seen is people use something like Stomp. Stomp is a message payload that has its own headers and its own payload. And you communicate that inside the WebSocket body. That's a bit of a hack. It's a bit of an unfortunate thing that we have to do that. It's a bit unfortunate that HTTP and WebSockets weren't built with the use cases of microservices and system design in mind. It's more about document retrieval protocol. So what can we do to escape some of these limitations? Well, a lot of different organizations have tried different things. Google created gRPC to build a service framework on top of HTTP. And that work led to HTTP2. That's a big improvement. But ultimately, HTTP still has lots of issues. It's not meant to be a service framework. It's meant to be a document retrieval protocol. So while things have gotten better, we're not quite there yet. Facebook took a swing at this. They created a protocol called RSocket. RSocket is a binary protocol that was created by Facebook, and it's natively reactive, okay? RSocket is a natively reactive protocol that is language and platform agnostic, of course, but the wire protocol itself is reactive. It also supports all the different common message exchange patterns. So if you want to have a service that does bidirectional communication, you can use RSocket, because in RSocket, there's no client service. It's just requester, responder. Either side can be a requester or a responder. You can send a stream of data in and get a stream of data out. You can send one value in and get one value out. You can send a single value in and get nothing out, or a stream in and get nothing out, or vice versa. You can do all sorts of different message exchange patterns with RSocket. It's also natively reactive. So if you imagine an HTTP client connecting to my reactive reservations endpoint, let's suppose that my reservations endpoint actually had 10 billion records in it, and I had to pipe all that out to the client. If a client disconnects from that HTTP service, my reactive web runtime called Spring Web Flux, which I'm running right now, would sense that the socket has disconnected, and it would cancel the production of the data that's being used to feed that HTTP endpoint. So it would cancel the stream coming from R2DBC or from MongoDB or whatever. That's back pressure in action, right? That's very useful. But it can only cancel, and it can only do it once. What I would love to be able to do is to say, I'm not going to ask for any more. I'll take the first 10 records, and I'll come back in an hour, and I'll request 10 more. That use case isn't well supported by HTTP. There's no true reactivity here, no true back pressure. RSocket is truly reactive, so you can do that kind of thing. It's also a stateful protocol. So a client and a service can connect, and one socket is maintained for the entire life of the application, and multiple requests are multiplexed through that one connection. This means that I can handle a good many more requests without the constant need to have to connect and act and make the connection and so on, and then dismantle that each time I have a new user or new request coming in. This makes my performance much better. So this is a very interesting protocol to have. It is also operationally minded, right? So how many of you have used the Spring Boot actuator? Actuator is a set of endpoints that you can add to your Spring Boot application. You install Spring Boot Starter Actuator into the class path, and voila, you have a set of HTTP endpoints that are mounted in your web application. These endpoints give you information about the uptime, the health, the metrics, things like that that you can use as a client to determine the state of the service itself. It's a very useful convention to have as Spring Boot users. If you know about it and somebody else knows about it, they can connect to your service's actuator endpoint and inquire as to the state of that service. Will this service be able to produce the response that I need? Is it otherwise too overwhelmed? Is it too busy, etc.? Very useful thing, but it's not by any stretch a thing that we can all count on in all services, right? It's just a Spring Boot-ism. It's not an HTTP-ism. There's nothing in the HTTP protocol that dictates that a service should be able to articulate its own health. But that's a very useful thing to do. So RSocket has a message frame in the protocol itself that clients can use to ask about the health of the service. This metadata, this out-of-band metadata about the status of the service itself is extremely useful in very smart client-side load balancing mechanisms. And you're going to learn more about the potential for that later with Spencer Gibbs' talk on Spring Cloud Gateway. That said, I want to take our little service here, our reactive service, and quickly turn it into an RSocket service. So we're going to say controller, and we're going to say @message mapping, greetings. And that's it. That's the code that I need to do to make my RSocket service. I'm going to start up an RSocket server on port 7777. Wait, a lot of Chinese around here, so we'll do 888. That's a good luck, right? Isn't it? Am I wrong? Good luck? Yeah, OK, good. So we're going to use that. Start up the RSocket service. It's up and running. And then we're going to go to start.spring.io. And we're going to create a client. And I'm going to use Kotlin because YOLO, right? And we're going to bring in latest Java. We're going to bring in RSocket support. And I'm going to bring in the web support just to have a thing that'll keep the thread open. So it'll be reactive web. OK? And we're going to consume that data from Kotlin, OK? UAO client.zip. All right. So now, OK. Got a new application. It's a client. It's a Kotlin application. It works on it compiles to bytecode that runs in the JVM. I'm going to show you some stuff you haven't seen yet before. This is all DSL stuff. But what you need to know is I'm going to customize the Spring Boot application context by adding an initializer. The initializer has a DSL that's available in Kotlin that looks like an Apache config file. So I'm going to define Spring Beans using this DSL. And what I'm going to do is I'm going to define a bean of type RSocket requester by injecting a pointer to the RSocket requester builder. And I'm going to connect that RSocket. I'm going to say that the RSocket requester should be connected statically to localhost 7777. 8888, and I'm going to call .block. I'll get that build back, that bean back, OK? So now I've got this. This is this, OK? Return that, OK? So I've got my bean. What's wrong with this now? Hello? Oh, it's not a subtype of any. OK, so we're going to say RSocket requester is this .block. And we should just be able to return that. Return builder equals this. And turn builder dot that. So it's a beans, and I got a bean inside of it. Add this context here. What is the deal? Ref RSocket builder. Val builder equals, RSocket client. It'll be an RSocket requester equals that. Oh. So in Kotlin, things have to be nullable. You have to express the nullability of a given variable in the compile time type definition. So right now, the compiler is saying, hey, you're returning a thing that could be null. It says RSocket null, right? That question mark means null, whereas it could be not null. And you need to say, hey, don't worry about it. I know what I'm doing. And usually, this leads to all sorts of confusion, just like what you saw me do right now. And usually, that leads to epithets, to swear words. And it turns out that, my friends, is the right channel to pursue. It's the right path for resolving this problem. If you want to solve this problem, you need to yell. Okay? So here we go. Return RS. Good stuff. And I was right. I could have just done this. I could have just said, let's do that, return, whatever, and so on. Right? If I leave that out, I get an issue. But there we go. So there's my bean. And actually, you don't need the return. That's implied. Okay? So this is my RSocket requester. I'm going to create another bean that's going to be an application listener. And it's going to be a listener for the application ready event. And I'm going to inject this builder that I've just initialized here, my RSocket client. I'm going to inject it here by saying ref RSocket requester. So the result of this bean up here is going to be injected here for the client. And I'll use that to say RSocket.route. And the route, of course, corresponds to the message mapping endpoint here. Okay? And I'm going to say go to the greetings endpoint, greetings, and then send some data. Well, the data has to be a bean of type greetings request. Well, I wrote this in Java, and I have getters and setters and all that kind of stuff. In Kotlin, this kind of stuff is super easy to express. So we're going to say, we're going to create a data class, this, val name string, okay? That's a constructor and a bean with getters and setters. We're going to create another class called the greetings response, and that's going to have the message, okay? So that's going to be the DTO for the data that we're going to send over the wire using RSocket. So the greetings request will say what? What name should we use for the greetings? How about Singapore, okay? And when the data comes back, I'm expecting a stream of greetings responses to come back. So I'm going to tell Kotlin to convert that into a stream of greetings responses. And then, with that, I'm going to subscribe to the results, okay? Whoop. Good. Subscribe. And each result that comes back, I'm going to print out the results. I'm going to say, let's print out the result. Each greetings response is a Lambda parameter there. I'm going to say, OK, gr.message, right? Message. Good. So I'm going to print out the results that come back. Now, I use gr. That's the greetings response. That's each value that's going to come back. You could just drop that as an implicit parameter if you want, but I chose not to. Let's get rid of all this. Good stuff. Okay, let's see. And we need to start this application on a separate port because obviously we have already got a web server running on port 8080. So server.port will be, let's say, 9999, and go. So this is going to be our RSocket client connecting to our RSocket service using the RSocket requester, which is going to connect to port 8888. It's going to create a connection at startup time. And as results come back, you're going to see those results reflected here in the console in the client. That's a binary protocol sending data over the wire and turning it into data that we can use. And in between the raindrops, it's not going to block. Remember, that stream is going to go on and on and on and on forever and ever and ever and ever. It has no end. It is endless. It is without end. It goes on and on and on and on, like the oceans and the skies and the stars and the bugs in your code. Infinite. Infinite. And that's okay, my friends, because in between the raindrops, it's going to free up that thread, and somebody else in the system can use that thread to produce another response. This is the true power of reactive programming. It allows us to handle more requests with the same computer. It allows you to, in simple terms, reduce your data center bill to achieve the same number of results, or keep your data center bill where it is and double the number of results, right? This is what you want. This gives you better resilience, better efficiency. It gives you a programming model that's optimized for the fact that things are asynchronous and event-driven and that they may fail. And it makes it very easy to express these concepts in ideas that would have otherwise been very hard to write. Imagine doing everything I've done today, asynchronous and all, using regular Java threads. Imagine using executor services and threads and runnables and countdown latches and cyclic barriers and phasers and semaphores and all that. It would have been a nightmare. We have a really interesting opportunity before us, my friends. This is just the beginning. We've talked about R2DBC and RSocket and reactive stuff as well. This is just the beginning. I hope you'll go to all the different talks today. There's going to be a lot of good ones on reactive programming. In particular, I would definitely check out Spencer Gibb. He's going to talk about Spring Cloud Gateway and the RSocket support for that. Thank you, Singapore. I appreciate it. Have a great day. I hope you liked it. Who had fun? Just curious. Who had fun? Good stuff. Who learned something new? Good stuff as well. Great. That makes me so happy. I love to hear that. Obviously, I'm a big fan of this stuff, right? Obviously, I'm wearing the spring T-shirt and the spring underwear. Big fan. Big fan. But you don't have to take my word for it. There are lots of different small organizations out there that are doing amazing things with Spring Boot, with Spring Cloud, and with this reactive stuff. So I mentioned Facebook. They built their Java client for RSocket on Reactor. Right? The Java client for RSocket at Facebook is based on Reactor, Pivotal's Reactor. That team, by the way, is comprised of people that came from Netflix, where they had RxJava, and they still chose Reactor. That's telltale. That's very promising. Netflix, of course, is all in on Spring Boot and Spring Cloud and Reactive. There's a small company that just recently had quite the day, right? Just recently, they had quite the day. This is a small company in China called Alibaba. They're going to be big. They're going to be big one day. Now, they had a big sales day, 11/11, right? That entire organization, everything inside of Alibaba, Aliyun, Alipay, AliCloud, Taobao, Alibaba itself, all these things are all based on Spring. And they're very, very keen on doing reactive programming. They're very keen on RSocket in particular. I go to Alibaba every year. I spend a week with them in their organization in Hangzhou in China to talk to them about what they're doing and to see how we can help and so on. This is the largest Spring usage on the planet, right? You saw last year, I don't even know what the numbers were for this year, but last year it was like $35 billion in one day. Did you make $35 billion in one day? Nobody? No? Okay, well, they did. Every single transaction that went through that system was powered by Spring. Every single one. And now they're looking at RSocket and they're looking at reactive Spring as a way forward. So there's a lot of interesting opportunities. All right, my friends, thank you.